examples that we're going to look at deal with some more algebraic ideas. Notice we have a conjugate in our denominator in this first example, and we have adding fractions in our second example, and we did put that hint in parentheses that we will need to find common denominators, right? Think back to elementary school, middle school. When we talk about fractions, you definitely want to make sure that you are adding fractions with common denominators. So before we get to that last example, let's take a look at this one. Before we can even tackle that the numerator is cosine squared or figure out what that does for us, we definitely want to tackle the denominator. So we'll go ahead and leave cosine squared the way it is. Okay, our denominator is now going to become this really drawn out foiling double distribution. Cosecant times cosecant is cosecant squared minus cosecant. Oh, I keep writing cosine. I'm sorry, guys. Minus cosecant of theta plus cosecant of theta minus 1. Okay, and then we notice that those two middle terms, opposite signs, they cancel each other out. And this simplifies to the cosine of theta all over cosecant squared of theta minus 1. Now, this for us is a Pythagorean identity. Cosecant squared minus 1 relates to this first, second Pythagorean identity of 1 plus cotangent squared equals cosecant squared. So if we head back down to that, 1 plus cotangent squared equals cosecant squared. So if we subtract 1 from both sides, we get that cotangent squared is equal to cosecant squared minus 1. So therefore, this next step is to take the cosine squared of theta, which is our numerator, and put that all over cotangent squared of theta, which is now our new denominator. Cosecant squared minus 1 is equivalent to that. Okay, so let's keep going. We can go ahead and rewrite this out. We don't really want to deal with complex fractions, so we can go ahead and rewrite this out as 1 over cotangent squared, which we know is just tan. So we can look at this as the cosine squared of theta times tangent squared of theta, which from there we know that cosine squared of theta times tangent, which is sine squared over cosine squared. We then see that the two cosine squareds, one in the top, one in the bottom, cancel each other out. And our final simplification is the sine squared of theta. And there we have it. You can go ahead and start working on your homework for Monday. Is this example of adding fractions? So when we add fractions, we want to make sure that we have a common denominator. In our case, they're really, really close, but they're not quite the same. So we actually want to use this idea of a conjugate to help us out, right? So we want this common denominator where it kind of relates to what we were given, but also will look the same on the other side. So for us, we're going to go ahead and multiply this by 1 plus cosine all over 1 plus cosine. Okay, and we're going to do the same thing to the other side. And we're going to multiply this by 1 minus cosine all over 1 minus cosine. Okay, and here we have it. So first off, we want to multiply the numerators together. So 1 times 1 is 1. And then 1 minus cosine is just minus cosine, right? Okay, all over. And for this, we're going to FOIL, right? So 1 times 1 is 1 minus cosine of theta plus cosine of theta minus cosine squared of theta. Okay, so that's our first fraction. Plus, all right, we will multiply the top. 1 times 1 is 1. Okay. 1 times cosine is cosine. And again, same thing with the denominator. We will FOIL that out. 1 times 1 is 1. 1 times cosine is cosine. 1 times negative cosine is negative cosine. And negative cosine of theta times cosine of theta is negative cosine squared of theta. So here's what's going on, right? If we take a look individually, these two terms cancel each other out and these two terms cancel each other out. So we're looking at 1 minus cosine of theta all over 1 minus cosine squared of theta plus 1 plus cosine of theta all over 1 minus cosine squared of theta. And if we take a look right here, when we add these together, okay, now that they have a common denominator, we can leave the denominator the same, 1 minus the cosine squared of theta, and this turns into just the number 2. Now, why does this turn into the number 2? Because when you add the numerators together, 1 plus 1 is 2, and then negative cosine plus cosine is just 0, okay? So now we need to keep simplifying, right? 1 minus cosine squared is actually sine squared because of the Pythagorean identity. So this turns into 2 over sine squared of theta. And remember, yes, we want our final answer as one final term, but if you think about this, we really don't ever want to leave our answer as a fraction. So we can probably simplify this just a little bit further and say that this is 2 times 1 over sine squared. And we know 1 over sine squared is cosecant squared. So this really is 2 times cosecant squared of theta, and that is our final simplification. So again, needing common denominators is a huge, huge piece to multiplying fractions, and that does not go away when we deal with trig identities. So, last and final thoughts. Hopefully you guys can see this on your screen. Again, please make sure that you finish the day 7 homework if you have not started it from Thursday, this one right here. Okay, it looks like that. Go ahead and open it. Well, you guys have paper copies, right? So go ahead and keep working on that as a paper copy. I'll put the key up there, but we'll take questions on this on Monday. So I hope you guys have a great weekend. I hope everything's going well with the sub. I hope your LTQ retakes went well, and I hope you have an awesome weekend. All right, bye-bye.